friends, myself Dr. Prakashdeep Manjankar, HOD Department of Mathematics, Dr. Ambedkar College, Chennai. Here I am going to deliver lectures on Laplace transform. As the name suggests, what is transformation means? What is transformation? Now this is the online class. As you think yourself, how many questions you answered yourself. You think what knowledge you have regarding mathematics. Transformation means any quantity or object change its place or its position or its properties by using some kind of parameter. Here we are studying Laplace transform. We consider a function f of t and we transform this function f of t by using some parameter s in the form of f dash of t. This is the meaning of transformation. Original function f of t. It can be changed or converted or transformed into another form f dash of t by using some parameter s is the transformation. But here we are studying Laplace transform. What is the definition of Laplace transform? We consider a function f of t defined for all values here t greater than 0. We consider a function f of t and it is defined for all values t is greater than 0. Then its Laplace transform is defined as, how it is? Here a Laplace of f of t is equal to integration 0 to infinity of e to the power minus st into f of t with respect to t. F of t is equal to integration of 0 to infinity of e to the power minus st f of t with respect to t. This is the definition of Laplace transform. What is t? Here t is strictly greater than 0 and it lies from here 0 to infinity for all values from 0 to infinity. What is the inverse of this Laplace transform? Inverse of the Laplace transform is written as inverse of L inverse of here capital F of S is equal to F of t. Do you clear this? Inverse Laplace transform of capital F of S is equal to F of t. What is F of t? Is the original function which containing a variable t. What is f of s? This is the transform form of parameter s. This is the Laplace transform parameter f of s. In this equation, suppose you may consider this is f of s and that will be given by equation 1. Laplace transform of f of t is equal to f of s. What is f of s? Integration of this form with respect to t is f of s. So what is the inverse of this? Is the inverse transform which is equal to f of t. And here f of t is the original function. S is the parameter will transform capital F of x. And equation 1 is said to be Laplace transform when it is if it is converges to some value of s. When Laplace transform is required, if integration of equation 1 or definition of Laplace transform converges for some value of s, and it can be written as here integration, which is the Laplace transform 0 to infinity e to the power minus st into f of t with respect to t is equal to here limit is b tend to infinity integration 0 to b e to the power minus st into f of t with respect to t. What will be the required value? It must be a finite. It is finite. Everybody clear this? When we come to know that some function is having a Laplace transform, or it is transformed by applying the concept of Laplace transform, if this equation converges to some value of s, and definition of Laplace transform is given by equation. Now we see some elementary function of Laplace transform. Laplace transform of n t to the power n, where n is positive integer. We are going to find the Laplace transform of t to the power n. As per the definition of Laplace transform, what do you have? L of f of t is equal to integration 0 to infinity e to the power minus st into f of t with respect. What we are going to find out? Laplace transform of t to the power n. So that what is f of t? Here t to the power n. So can I write here L of here t to the power n, here integration 0 to infinity a to the power minus st. What is f of t is? Here t to the power n with respect to t. Once you given the value of given function f of t, then just you integrate this integration with respect to t. How will you work out the integration of this with respect to t? Anyone can think yourself and verify whether you correct or not, because this is the online class, obviously. That you have been already studied in your basic level, 11th, 12th standard. To find the integration of this integrand with respect to t, we are applying an integration by parts. What is integration by parts? We evaluate the integration of a given function when the function in the form of product of two functions. We consider these two functions, first and second function, as per the rule of LIAT. What is LIAT? Do you remember? Logarithmic function, inverse function, algebraic function, trigonometric function, and exponential function. And we consider the order of this function as per the occurring of this alphabet. What is first function over here? Here t to the power, this is algebraic, comes first under the order of LIT, and second function is exponential e to the power and then applying the integration by parts. What is integration by parts? That you know. Integration of first or second function with respect to x. Here first function integration of second function with respect to x minus integration and derivatives of first function into integration of second function with respect to x and this complete bracket with respect to x. This is the integration by parts. Now by applying integration by parts, we are using over here t to the power n is the first function. T to the power n. Integration of second function 0 to infinity e to the power minus n with respect to t minus integration 0 to infinity bracket t by dt of first function t to the power n integration of here second function t to the power minus n with respect to t bracket close and this total integrand with respect to t. This is because of the integration by parts. Now just to evaluate the integrand by with respect to t. What is the integration of e to the power minus st with respect to t? Here t to the power n. E to the power minus st by minus derivative of the power of exponential minus st with respect to t is minus s 0 to infinity minus integration 0 to infinity derivative of t to the power n with respect to t here n into t to the power n minus 1 integration of e to the power minus st with respect to t here e to the power minus st by minus s again this with respect to. Now by substituting this upper limit and lower limit, what do you know? E to the power minus s minus infinity minus e to the power 0 and e to the power minus infinity is 0. E to the power minus infinity is 0 minus e to the power 0 is e to the power 0 is 1. But we are replacing this value t by 0. Then what we have? This bracket is must get vanishes. And then what is the rest term over here? Is equal to minus minus plus n by s is constant with respect to t. It should be taken out. And that we have here n by s integration of here t to the power n minus 1 t to the power minus st with respect to t minus n by s out of integration. What is the rest term? T to the power n minus 1 into e to the power minus st with respect to t. Again we are applying the integration by parts. Then that we have n by s integration. First function is t to the power n minus 1. Second one is e to the power minus st. E to the power minus st with respect to t. Integration 0 to infinity minus integration 0 to infinity. What is first function? Is this. Can I write directly the differentiation of this? What is the differentiation of t to the power n minus 1 with respect to t is? Here t n minus 1. T to the power n minus 2. Again integration of e to the power minus st with respect to t is e to the power minus st by minus s in this with respect to t. Because of the same fact, this lead to 0. This is n by s. Integration of part first function t to the power n. First function t to the power n minus 1, integration of second function minus, and directly we find the value of differentiation and then integration of second function with respect to t. Now, n by s. As per our technique of this, because of this t to the power n minus 1, so this term will get vanished. And then minus minus plus n minus 1 by s, n minus 1 by s, integration. What is it? 0 to infinity. Here t to the power n minus 2 into e to the power minus st with respect to this. Now repeating, power तो बढ़ते ही जाएगा, it is increasing up to the n times. So we are repeating this process of integration by parts. Right. Then what we have? What is the finalize? By generalizing this result, first after when we apply the integration by parts, first then what we have n. Second time n minus 1. Then third time will be n minus 3, n minus 4, up to n times means 1, 2. So can I write here n minus 1, n minus 2, here 2 into 1. What is it? First time s up to n times. S n times. And then what is rest over here? Here 0 to infinity t to the power n minus 2 into e to the power minus st with respect to here. Sorry.
0. T raised to power 0.
We are integrating this up to the n times. 2 is replaced by n plus n minus n 0. T to the power 0. It means what we have?
Only 1 here.
Is that clear? Now, n minus 1, n minus 2 up to 1. It means that we have n factorial. Above. S up to n times. It means s to the power n. S n times means s to the power n. Now integration of this with respect to t. Here e to the power minus st by minus s with limit 0 to infinity. And then that we have 1 n factorial s to the power n into minus 1 by s is taken out, substituting upper limit e to the power minus infinity minus e to the power 0. Does everybody get it? Now, e to the power minus infinity. Minus infinity indicates that it is very lowest value. Means the value of e to the power minus infinity is 0. And e to the power 0 is 1. Minus minus plus. It means that we have here n factorial by s to the power n into 1 by s. S to the power n in denominator s. Base is same, so that addition of its power s to the power n plus 1. So that we have Laplace transform of t to the power n, L of here t to the power n is equal to here n factorial upon s to the power n plus 1. What is S here? S is strictly greater than 0. So what is the Laplace transform of t to the power n? Laplace transform of t to the power n is n factorial upon s to the power n plus 1. And that we are using this directly just in the feature consequences. Okay. Next. Here we are collecting the standard result to apply in the future. Here L of Laplace transform of 1 and Laplace transform of again by applying the definition of Laplace transform. What is 1? Is the function. We can express this in the form of t to the power 0. It means f of t is equal to t to the power 0. So L of here t to the power 0 integration 0 to infinity t to the power minus t f of t here t to the power 0 with respect to t. Here t to the power 0 is 1. On integrating this t to the power minus st by minus s with limit 0 to infinity. Again can I write minus 1 by s is constant with respect to t. So it should be taken out. And then rest of the term is a to the power minus st. And substituting limit t to the power minus infinity minus e to the power 0. And then here 1 by minus 1 by s. E to the power minus infinity means 0. E to the power 0 means 1. And minus minus plus that we have here 1 by s, which is s is greater than 0. Or directly this result is obtained by applying the earlier one. Here t to the power 0. It means this is in the form of t to the power n. What is the result of t to the power n? Here n factorial upon s to the power n plus 1. What is it n over here? N is 0. So what do you know? Here 0 factorial upon s to the power 0 plus 1. 0 factorial means 1. 0 factorial is 1. 1 by s, where s is greater. This is the percentage that we are finding by applying the definition, and this is by applying the direct rule. And then limit of L, and then Laplace transform of L of t. L of t. By applying the standard result, that is Laplace transform of t to the power n. What is it? Here n factorial s to the power n plus 1. What is it? N over here 1. N is 1. 1 factorial. 1 plus 1. That is 1 by. So Laplace transform of t is 1 by s square. Is that clear? This is the standard. And then